Hey everyone, and welcome to episode 10 of Coding Tetris. I am John, and let's do a recap of where we left off. So the last thing we did is, well, some of the things we have done is we have hard dropping working, we have the ghosts showing and everything. We could place tiles around, and one cool thing we have is if I'm going to click here, that cleared the row and all the other rows above that moved down. And we could clear up to 4 rows at a time. So if I draw something that's like this, and then I flip like this, and I slam it down, it clears 2 rows. This will clear 1 row. Boom, boom, boom. And you get the idea. So yeah, I'm just enjoying that. I'm just really enjoying that. Okay, so where the heck did we leave off? What are some things we could do? The row clearing animation and the next Tetramino cue. I think we could start working on the next Tetramino cue. So let's think about how we want to do that. And what that's going to look like is maybe over here going down, there's going to be the cue, and instead of just giving us, like every time we slam one down or place one down, instead of just giving us the exact same Tetramino that we have, instead it will have a cue and rotate through the cue and give us a brand new Tetramino, and it will be somewhat random, well, pseudo random. All right, so I'm trying to think of the first thing I want to do this, and I think what I'm thinking is just starting with no randomness, just testing out cycling through a cue. And what we'll do is we'll just kind of set the cue, so this will be the I piece, the Z, the S, the O, the J, the L, the T. I think that is all the letters. And what we will do is, this is our cue. And we will start on the I, so it'll point here, and then after we do the I, we'll point to the Z, and after the Z to the S, and so on until we get to the T, and then we will wrap back around to the I. And maybe we want to show 5 pieces in the cue, so we'll always make sure, so if the I is currently in the active cue, so like here is our Tetramino, and let's say the I piece is here as the next thing. In this cue, we will see the Z, the S, the O, and the J in here, and then we won't see the L or the T. And then what's kind of going to happen is if we are, say, pointing at the J, we will see the J, the L, the T, the I, and the Z, and then get cut off here. So this is like the 0, 1, 2, 3, 4 position. So we'll see like it kind of wraps around like that. Yeah, I think that is how we want to start, just so we could get that going. And then we'll think about, okay, well, how do we make this random now after we could see our first draft of the next cue? So let's go to here. And I am just going to make the next cue. So what am I calling that? Persistent state. And I think for right now, what we want all we would need to capture really is the next Q, next Q index, I suppose. So that's an I. And I don't super love this name just because next usually implies like it is the next index in the queue or something. But in this example, the next queue is one particular thing. So let's just call it the tetramino Q index for now. I don't know. Okay. So that starts at 0. And what we'll want to do, so if we go down to our update, and we'll find a spot that we could put this next Q position, and you know, I don't know where that would be. I guess right here would be as good as any, and then we'll figure out if it's not. So the tetramino Q. And what we'll do is have the actual Q. So the tetramino Q, and we will have that be tetramino type. And then we'll just have the I, the S, the Z, the T, the J, and the L. And I think that that is all of them. And then what we want to do, so let's just first draw it. So let's see where we are drawing the active tetramino. Draw falling block. So this is where we draw the active tetramino. So let us now do that for the tetramino Q. So for T-type in tetramino Q, or actually what we want to do is for what we want to do is for I in the visible and we'll say the number of visible tetraminos in the Q is 5, so we will do that 5 times. And then what we'll say is that the index is equal to the PST dot index tetramino Q index plus the I here mod the length of the tetramino Q. And what this is going to do here, and why we're doing this, is so we want to get the number in the Q. So like the number in the visible Q that is showing. So what we want to do actually, I think, is rename this to head. Okay. Because it's representing where the head of the Q actually is. Because this is like the backing array of the Q, but the Q actually starts, so say that the head is 0, 1, 2, so it's on the Z. The Q actually starts on the Z, and then it increments from there, so the last element would then be an S. And what we're doing is we're getting the number of the visible tetramino in Q index. So let's call this that. So So what we're doing is from the head, we are adding the current index in the queue to it, and then modding by the length of the tetramino, because say that this ends up being so 0, 1, 2, 3, 4, 5, 6, 7. So let's say we get like an 8 or something. Well, 8 is more than the number of elements here. So when we mod it, what ends up happening is that this 8 ends up wrapping around to the front of this array and then probably being like S or Z or T or something. And the reason I'm doing mod here, so I don't need to do that, I'll just do that. I kind of do mod by habit because that takes negative numbers into account. So if you get into the negative numbers, it will wrap around in the pot like to a positive number. So the Q index, and then the tetramino, the T type, let's just call it, equals tetramino Q, and then the Q index. Cool. All right. So then what we're going to do is once we get the T type, so let's see. Yeah, I think how we kind of want to do this is something like this. Like just have a draw tetramino function, and it takes in the position. So let's have the Q start pause, and then that will be the Q start pause. I mean, hey, let's just say it starts at so if this is like a 1280 by 720, let's just say it starts at 800 for now. We're going to change that. 820. Something like that. And then what we'll do, so do we have like block size? I think the LSP is busted right now, so let me all right, we're back. So what we're gonna do is, we'll just set the Q entry height to maybe 4 times the cell size. Let's just do that. So that's like the height of each entry in the queue, and actually want to do that, I think. Q equals expected a type, tetramino type, and then tetramino type. Oh, because we're missing the O. So let's put the O there. Bare enumerated array little is most at field value. So what we'll do is lane tetramino type. Oh, okay, that works. But we could also we could also do this. And then that will infer the size of this array where they're all of tetramino type. So what I think we want to do, so if we draw a tetramino, what we kind of need to take in, so let's tetramino equals tetramino, and then it has the rotation, and we'll just say it's 0. The pause, okay, I guess it has a pause, so Q start pause, we'll just say cursor. I like calling cursor if it's like something that's intended to change while you're drawing something. So we'll set that to cursor. And then, why does that not like it? Oh, I guess that makes sense. Because the position is, so like basically this was an int, like 2 int, because we were expecting that this is a position within the play field itself. But what we want to do now is have this in screen space. So we'll do draw Tetramino in world because it's not necessarily in the play field. And let's just start with this. So we pass in the cursor and then the t-type and then the rotation. And the idea here is that we're not necessarily drawing a Tetramino in the play field, we are drawing it in the like the overall world, so it could really be placed anywhere. It doesn't just need to be placed in the play field. All right. So draw Tetramino in world. And then after we do that, we want the cursor Y value to plus equal the Q entry height. And then we keep going around and drawing that. So let's grab this guy and move it up here. Oops. T-type is a Tetramino type. And then this is the rotation, and it is a rotation. And let's get the drawing code finally here. And so we have the cursor. And maybe we could also take in the block size too, I realized. So rotation, and then block size, which would be F32, because this could be in floats, it's not specific to the grid. So playfield block to screen space rectangle. So I think what we want, Tetramino so the shape in the playfield space, that just returns all the blocks, so 4 to ints. So if we get our Tetramino descriptions and we access the Tetramino type, and then the rotation shapes is the rotation, and then that gives us a Tetramino description. No, because the rotation shapes give you a Tetramino shape. So T-shape equals that. And then what we want is in screen space. Actually, I think it's fine to use this for now, because then we'll scale it. So what I'm going to do is copy this out of here and just put it somewhere in here for now. And then this would be pos x and pos y. And we want to get, so I think we do want to get the T shape in P space. No, we don't. We do just want it relative here. So T shape, and then the block pos, block size. And then we just draw the block, correct? And then the type of the color. I don't quite know if this is correct, but I guess we will find out. So we need to take the cursor, the t-type, the rotation, which is 0, and then the block size, which let's just say 40, just so we could like see if it's good or not. All right, and well, let's just see what the heck happens. All right, cool. I think it just worked. And let's change the size there. So let's move this over here. I am so happy that that just kind of worked. Okay. And what we want to do is go in here and then, oops, down here. So instead of, so the cell size, we'll say the block size equals, and we did 20, and I kind of like that they're smaller. And then we will make it so that this block size times 4, and then down here, first let's make this correct, and then in here block size there. Okay, cool, and that seems more correct. So we got our I, our S, our Z, our O, our T, our J, our L, and let's say that the Q index is, so head, or the head rather. So let's say that the head, we'll just make it equal to, how many are there? 0, 1, 2, 3. So let's set it to 3. Play it. Okay, and then we have O, T, J, L, I. And then let's set it to 5. So we start at J, L, I, S, C. Hey, looks good to me. So now I think what we want is that when what we want is we want to keep, every time we place something, so if we place that, it will keep cycling through the queue, so we just need to adjust the head. So let's look at where we do that hard drop, because I think the hard drop is the only place right now where we should be needing to think about it, because we could, technically we still have some code to just place it at any arbitrary place. But for right now, we just need to do it in the hard drop. So when we're here, let's just pst head plus equals 1, and then PST tetramino Q head mod equals and then the length of the Q. So we do need to know about the Q, it just can't stay in here. And I'm just gonna probably go ahead and throw it in the persistent state. I think I'm just gonna throw it in the persistent state because eventually we will want that to be persisted anyway. So what the heck, let's just throw it in there. Where is it? Oh, I guess I have my caps checking on. All right, so up here we will just have the tetramino Q, and we will just make that for right now. The length will be the tetramino type, and it will be the tetramino type. Okie dokes. So, what we then want to do is tetramino Q is we will just set this equal to it right here. So PST and then PST dot tetramino Q, and then the length of PST tetramino Q. So I am just gonna leave this being set here, except it is being set to the PST tetramino Q. That's fine, I think. Well, let me just make sure it gets to the same exact thing. And then what we want to do is here, then yes, the length of the PST tetramino Q. And let's see if that works. So run it. And I think so. Let's send it down. Oh, so what we want to do is reset active tetramino. We want to probably also pass in, or I guess get out and reset active tetramino. So, oh, here we go. Active tetramino dot pause equals that, and then active tetramino dot type equals to PST tetramino Q tetramino PST tetramino Q head, and let's see if that does it now. So let me just erase a bunch of these and place it. Okay. I'm just going to play for a little bit. Boom, cleared it. Boom, cleared it. Boom, boom. All right, I'm done enjoying myself. So what we'll do now is probably I think we should put this stuff in here, maybe, probably, I don't know. Why not? For now. Who cares? It's okay. I mean, I do care. And who knows if this is the greatest idea, but that's what we're doing. Okay, so what we want to do now is actually have the queue randomized. And how we want it randomized, or at least how I'm thinking about it, so one of the big things with the randomization is that you don't really want to have like every single element being random. So let's just say this is our queue again, right? And if we were making every single element completely random, what you could end up with is something like this: Z, Z, I, J, I. So you'll notice how like we have 2 Z's, 3 I's, a J, and another I. And I guess in this situation, it's the player would like this because a bunch of I's, like Tetris players love I's. But they hate Z's. So if the shoe was flipped, is that even the phrase? But you can basically enter states where you have too many of the same tetramino, and it could be a very unpleasant experience for the player. Like if you get a bunch of Z's in a row, that's not fun. And what you kind of want is that they're randomized sort of equally in here. So I, O, and then J, T, Z, I, S, O, L. So you pretty much want them so they're sort of randomized equally. And let's say that this kept going. I'm just going to put a marker here to put the halfway point. So theoretically, sure, you could have an L right after that and maybe another O, but things will get mixed up again. So this is like a J, maybe an I, a Z, and let me just like finish it off for completion. So S and then T. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. And pretty much this is a much more pleasant, evenly balanced queue. So if you kept going down the line, yeah, you would experience like one place where there's 2 L's and then an O right after, sort of right after another O. But it's not as unpleasant, and it feels a lot more balanced and fun, you know? So how I'm kind of thinking about that, and like when I'm looking at this screen right here, how I would think of it is that we have our list that we already have of our tetraminos, right? So I'm just going to write them again for completion. So J, T, Z, I, S, O, and L, right? And what we kind of want is, so say we're going down the queue and we go from here to here to here to here to here to here to here, and then we finally hit this point where we have enough space for a whole selection of all the tetraminos, all the tetramino types. And what I would probably do at this point is shuffle this up. And what we would kind of do is just like randomly pick different elements here, like so. And sort of like shuffle them up. So we shuffle this part of the queue, because once we move past it, we don't see it anymore, right? And then what we do is we keep walking. So this guy goes to this guy, 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 goes to this guy. And then what we do is shuffle up this part of the array, right? And I think that's what we'll do, is we'll basically have an array that's twice the size of the number of types. And then after you reach the halfway point, it takes the first half, shuffles it, and then when you reach the first part, it then takes the second half and shuffles it. Does that make sense? All right. So let's just start. And how we'll sort of start this is just make an array that is 2 times the types. And we'll just straight up initialize it and we'll randomize it once. So we'll randomize this section, then randomize that section, and then we will just keep looping through it and not randomizing it. After we get that down, then we will go and actually make sure it randomizes when you hit the certain indices that trigger a randomization. So what I'll do is in the persistent state, and what we'll probably do at this point is just put the tetramino q in its own struct, and we'll just say the tetraminos and make it 2 times length of tetramino type, and it will be a tetramino type. And then we will have the head. And then this will become the tetramino q. We could get rid of this. And what we will do is just get it so that this works. So pst tetramino q, tetraminos. Okay, and then that. Oh, let's just call that data. All right, since we're setting the logic, and let's just build that so we can see where we get errors. And this will be a 2 times tetramino height. And we will, let's just do this in reverse now. Okay, and then turn this to dot head dot data, q dot data. Okay, so let's do that again. Okay, we see the 2 J's, and then it starts to reverse, and then we should see 2 I's. Yep, and then it starts to go around. So what we want to do next, or at least what I think would be nice to do next, I am just... So what I want to do is I'm going to start working on the randomization. And I want to make sure it's right, and I want to be able to see the entire queue. So what I'm going to do is down here, debug block size equals 10. So what I'm going to do is I'm kind of going to draw them. Since I have more space down here, I'm just going to draw the entire queue down here just so I could see the entire queue. And that will help me easily see whether or not it's good or not. And then instead of this, let's just make it go up by 10 times 4. And we will actually start at queue index, and we'll go up to the length of the tetramino queue.data. So now we are just going to straight up go from the beginning to the end and see the stuff in there. So let's do that. Okay, we want the cursor start at 0 and be like 700 and 700, 680, something like that. And then debug cursor that. Four. All right. So now we could see the entire queue. That's cool. And if I erase all this stuff, and then I do that, so you'll see, so if I slam, so that's the O, the blah, 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 blah. Yeah, you get the picture. And let's actually also draw. So if Q index equals PST Q head RL draw rectangle rec. So what we'll do is just draw like a little thing. That's like 2 by 2 or something like that. RL white. And let's actually draw that. Yeah, so let's make that a 6 by 6. So now you could see that there's this like little dot that is showing us the current place in the queue. And you could see, like, so right here, this is where the dot is, and right up here, that is the queue item. And I'm putting that there so I could see that basically when it hits like this part right here, it will shuffle all these, and when it hits here, it will shuffle all those. All right. But first, like I said, I just want to shuffle it initially. So let's go here. And let's see. Okay, so it looks like Odin has a shuffle facility in their math library. And how we're going to do it is that right here, this data will have like all the tetraminos basically listed out, and then we are going to shuffle it up, and then we're just going to copy paste it into the subsection of the queue that we want to do it into. So how we would do that is I'm just going to call it the tetramino bag, and that will be I L J O S Z T. So yeah, basically every tetramino type. And what we're going to do is for I 0 all the way up to, let's just say, I in length of the tetramino type. What we're going to do is get the queue, the data, and then this I. And actually, we're going to do shuffle it first. So rand.shuffle tetramino bag, the whole thing. And oh snap. So what we could do is this. So we can just go through the length of the data so the Q index, and then what we'll also do is the all tetramino index, and that will be the Q index mod the length of the all tetraminos. And then the Q index equals the all tetramino index. So, okay, so what I'm going to do is actually populate the entire queue with this 2 times. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Fill it 2 times. And then because the random shuffle takes a slice, what I could do is just shuffle the slice of the tetramino queue that I want. So we come down here, and this goes from 0 up to, I think, the length of the tetramino type. And then what we do, I think, is start at the length of the tetramino type to the end. That's not the tetramino bag, but it is the PTSD tetramino Q data. All right. So what I'm doing is I'm just specifying all tetraminos. I'm copying it essentially twice. That's what this is really doing, like the Q index mod the all tetraminos. Well, let's just like actually verify that that is correct, that we're thinking about it right. Okay. So we also need to make sure that we're not overwriting it all the time in the update. So tetramino q.data. All right, yeah, we need to make sure we aren't overwriting it every time. And if RL is key pressed R to randomize it, let's just do that again so I don't have to type it all out again. I know it probably would have been faster to just restart the app. Okay, but I want to do that. So it looks like we have 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. Let's randomize it again. I'm just checking to make sure it's good. So yeah, I think that looks good because I don't see a tetramino repeating in here anywhere. So I think that's pretty solid. And what I want to do is something like this. So if I'm just going to take all tetraminos and put it and then see where I'm using it. So I think what I could actually do is just tetramino type, the length of tetramino type, and then tetramino type, just kind of cast it back to a tetramino type, and then just get the type out of there. All right. And then what I want to do is, where is my reset? So in here, what we want to check is if the PST tetramino Q head equals 0, then we want to shuffle the second half. Else, if PTSD tetramino Q dot head equals the length of tetramino type, then we want to shuffle the first half. So let's just say reached first half. Then it reached second half. Just to hopefully drive this point home. And then we will build that again. And let's keep going. And then when we get, I think, to this guy, it should trigger. Yep. See that? And basically, because you only see visibly like up here the next 5, you won't see this like change in the next queue area. See if I keep doing that? That is really satisfying. I don't know if it's satisfying to you, but that is very satisfying to me. I could do this all day. I'm serious. All right. And we also have the ability to just shuffle it up on demand or keep going. This is so fun. I love seeing all the tetraminos on screen. It is so satisfying. All right, so let's just verify that again. So we do the initial shuffle, and then we do it again on the hard drop. Well, we place it in here. And then let's look for our, we do that. And we don't need to do that. We can just do that. Force shuffle key. So let's just say should force shuffle. So we could force a shuffle too if we want. Alrighty. And let's move this more down. Yeah, let's like do some like kind of cleanup here. So we will move this down to the playfield position Y, maybe? Yeah, so it's like aligned there. And then I think what we'll do is playfield position X plus playfield width times cell size. And then plus some padding, so like maybe 20 padding. Okay, so that is basically that if we move the playfield around, so if we look up playfield position, that's defined up here. So if we were to move this farther this way, the next pieces travel with it, as you can see. See? Alrighty. And maybe let's make this like 16. Oops. No. 16. Make them even smaller. And then let's, yeah, let's just leave that there for now because that's fun. So we have draw tetramino and world. And all we do is we get the T shape and then times it by the block size that you want. And it draws a rectangle. So I'm gonna just start putting some stuff into different files because I'm starting to see You know, like actual legitimate patterns that are forming. So I'm going to make a tetramino file. And I think this will be tetramino. Our first actual breaking stuff off into files. So we could also import, let's move this over here for now. So we could also import raylib, because we are using some raylib things. And then let's put some tetramino stuff in here. Oh, we have get tetramino color. Am I using that anywhere? Get tetramino. We are using that places. And I actually want to replace it with tetramino get color. Similar thing here, so let's just control F for that. So get tetramino shape. We'll do tetramino get shape. And then let's start putting play field in its own area. Say, oops. Rename this to play field. Yeah, so I think that's like all I kind of want separated for now, because like there's some functions where they don't necessarily live, like it's like, do they live in tetramino or do they live in playfield? Like tetramino to playfield space, things like that. And I don't necessarily want to be worrying about where should something live. I'm more just like separated it out because, at least for me, it was becoming quite cumbersome to scroll a lot up to those things, like scroll back and forth all the time. So I figured I was like kind of going to multiple places at once, like going to like the more implementation, like the update side, and then going to the utility function side. So I just think it might be a good idea to separate some of that stuff out. I don't know, it's more of a feeling than anything. But yeah, so today let us go to our to-do. So we did the next tetramino queue, and I think we did a pretty good job of it. So on stream 11 we will do, which these aren't even streams anymore. What am I saying? These are just sessions, because I'm not streaming these anymore. I'm just recording them. So what we're going to do next time is row clearing animation. Count number of lines cleared. So we did the rotations. We did the collisions, or at least the wall collisions. We didn't do the soft lock. There's a block in each column. Okay. So I think we're getting kind of close. Okay, so row clearing animation. Yeah, I think I kind of want to do that. Not right now. I think I want to work on some of this other stuff first. So I think what I want to do is make playfield larger than visual playfield. And with that kind of comes with like game over reset playfield. So what I kind of want to do is in here, if you go into this area, like if a block gets placed above this line, then we will just wipe the playfield and start from scratch. And that kind of goes hand in hand with making the playfield larger, because what we're going to do is we're going to go through the playfield like in a loop and just check was anything placed above here. Or I guess we could just check like on placement, we just find out where the tetramino would get placed in the playfield space, and then like handle it there. So I think that that is what we will do next. And I don't necessarily think that will take the whole time. So what we could also do is, I think, yeah, then we could start working on falling and soft locking. So yeah, let's put that for next time. Not soft drop, we'll just do falling. So they'll move downward automatically and then lock into place when they reach another tetramino, basically, or another block or something in the wall, in the playfield. So I think that's what we'll do for session 11. Alrighty, well, I will see you next time. Thanks for sticking with it. If you've been sticking around the whole time, I hope that this is valuable to you and you're getting something out of it.